one thing. If I see the script extension, in like if we create a script in PyCharm, it will come with .py extension. But here it comes with .ipynb.
You can. There will be a button here which you can actually download as IPy.
Then we can.
You can convert Python to py and all.
So it's a Jupyter extension.
Right. So here you can see. Okay, so import broadcasting. Okay, so let me create a vector here. Import numpy as np. Okay, np dot array 1, 2, 3, 4, 5. You have this a So what do you see here? You see two vectors. Okay, imagine A is representing one data, B is representing one data. Okay, what you have to do is you have to find distance between these two vectors. Okay, one of the simplest form of distance between these two. Or what will you do? You'll just do A minus B, isn't it? Right? It will be distance between two vectors. Cool so far? Of course, if you want to calculate, that root, distance between two vectors will be square of these terms, sum of square of this, and that also you can do. But basically, this is what is very basic distance between two vectors, right? Okay, so this is what vector operation means. This is not vector operation. You have two vectors. You can directly do the operation only and only if the shapes are same, not otherwise. Okay. So this was vector operation. Now if I write something like this, a minus 2, what does it mean?
2 will be subtracted to each and every element of A.
Vector operation. Vector and scalar operation. Understood, right? Okay, what you're doing here, you're defining the difference between vector and scalar. Okay, so you have A minus B, that is the distance between these two, and A minus 2, this is basically difference between vector and a scalar. Okay, so if you do this, okay, so there's something very important to understand here. What I mentioned earlier, you cannot do vector operation directly, right? You cannot do this vector operation directly. You have to convert the scalar value into vector before you can do the operation. Okay, see here. See, you have this A means this, right? One, two, three. So 1, 2, 3, 4, 5. Right? When you do this, this is a vector value, and this is a scalar value. Suppose you have to find difference between them. It is technically not possible. Okay. So how NumPy does it? NumPy does it using this technique, broadcasting. What it does in here, it tries to convert this data in the same shape of this. What is the shape of this guy? 5, comma,
Comma.
right? This is the shape of this guy. It tries to convert this 1. What is the shape of it? 1. It wants to convert this into 5, comma, right? How does it do? It actually broadcasts. Broadcast means repeats this 2 content. Understood, right? Right. 2. Got it? It actually, this is known as broadcasting. Okay, this is known as broadcasting. That is how, because of broadcasting only, this operation is successful and gives you this result. Clear? First question, first point. Second point. Suppose you have a matrix. One, two, three. Okay. So you have this. This is your C, and this is your D. Say. Okay, this is your D. So you have C and you have D here. So okay, so what you have here, you have to do, you have to subtract C minus D. Right? You have to subtract C minus D. So C minus D. Again, this works, right? Got it, right? What you're doing operation here, this is a matrix and this is a vector here. You're doing operation between them now. Okay. You have a matrix, we have a matrix. One, two, three, 4, 5, 6, 7. And you have an array which looks like this. Two, two, two. Now what you have to do, you have to actually do subtraction operation between them. How can you do that? Again, remember the rules. You have to be on same shape.
Yes.
How can you convert this into this to shape of this? Huh?
Yes.
Broadcasting.
Broadcast.
Because you can repeat it very easily here.
But we're not doing it, right? It is internally.
Internally
done.
doing. That is what broadcasting is.
Okay.
Broadcasting means whatever reshaping you are saying, right? It is all doing it internally for you. Okay. So what it will do, it will replicate this element. Just replicating this element.
So broadcasting is done only when we perform any vector operation, or there are any other scenarios as well?
There are, this is the operation only case, only when you are doing vector operations. Okay, got it, right? So you are replicating this content here. This is internally happening for you. That's why nobody is complaining about it. Otherwise, you would complain that, shapes not same.
But if you put some 4 elements, like 2, 2, 2, comma 2, like that D, how will you go?
Exactly. That's what I'm going to do next. Okay, so you have this case. Let's go to the next case. Say you have E. E is something like this. CDE. Okay, so E, if I do, it looks like this. So can I do C minus E? How it will happen? Is it possible? Is it possible? Can it do broadcasting for you here? Like this is your E, right? 1, 1, 1.
Will automatically take, I think, latest one.
Of course, I could have 1, 1, 1, 2, 2, 2, 3. Can you do broadcasting of this so that it reaches this shape?
E is not any.
This is your E. This is your C. Can you? What is the shape of this? 2 cross 3, right? Okay. What is the shape of this? 3 cross 3. Can you do some broadcasting in E so that it will become similar to this? Can you repeat something?
Normally, if we have only one, or like if we have one vector, then only we can do it.
Absolutely. So that's what is important on broadcasting. What is important is, anything you will be able to repeat as long as that has one dimension. Right? That is the thumb rule. You cannot do this operation. You cannot do this operation to complain that the shapes are not same.
But what if the shapes are in multiple of each other?
Even then it cannot. It needs one dimension only.
Only one.
So in one dimension, there are 4 elements. Will it work? No. So one dimension.
One dimension, but it has to be of same.
I think by default it will take first 3 elements.
No, nothing like first 3. Okay, so remember we had a matrix. I think A was a matrix. No, what was the matrix? Oh, C, right? Can you tell what happens with this? How does this operation happen? This, as you expect, is going fine. How does this operation internally happen?
I think we create a broadcasting 555. Same as C. It will automatically create 3:3 internally.
First it will create shape with 3.
Right.
Then it will change.
Right. So 5 will be converted. The scalar value will be converted into a matrix of 3 cross 3.
Yes.
First this way, then this way. Right. So it is possible only when there is one dimension. If it is a array of 1, 2, there is no way it can achieve that. Right. Right. So wherever it is one dimension, there only it can replicate. Make sense? Okay. And suppose really you have to do this operation C minus C. Can you really do that? Can you do some manual broadcasting? Suppose you have to do C. What is a C shape? B shape. Not B, D shape, right? E shape. Can you do any broadcasting between them? If you have to do. What is the thumb rule of broadcasting? So that happen, and when either the shape should be same, or wherever they are not same, one of them should be 1, so that it can repeat theirs. Understood, right? So what you have to do? So this last dimension it is same, but this dimension it is not same. What you can do is you can make it 1.
Or we can delete one dimension also. Delete one dimension also.
No, you cannot delete dimension. Okay, but you can add one dimension there. Because for adding one dimension, you don't have to. So you can do this 1 cross 3 cross 1 cross 3 cross 3. Dot. Right. So see, this is the shape one, and again, reshape 2 cross 1 cross 3. Got it, right? So what you can see here, either the size is same, and wherever they are not same, it is 1, right? And whenever it is 1, it means in that dimension it can repeat. Okay, right? So actually when the operation really happens between them, okay, you can see what is the resultant. The resultant shape is 2 cross 3 cross 3, because it will replicate there. You're adding one dimension whenever there is a mismatch in shape, and wherever there is one dimension internally, it means it can replicate there, right? So it can replicate here. So 1 3 3 means the output will be 2 comma 3 comma 3. Make sense?
Okay, you are adding to reshape,
Right.
not to element.
One dimension, only one element is there, or four, I think 4 elements is there.
No, there is no daily. If you add one dimension, right, you don't have to add element over there. It's just height you're including to that, right? Because this shape is what, 1 into 3 into 3. It's same as 3 into 3, right? Got it, everybody? Okay. If you have got it, I will give you some assignment on. So in NumPy, generally people ask this on broadcast because it is little complicated to understand, right? So what is the thumb rule over here? Thumb rule is, if there is a mismatch, what you do, you can add more dimension there, and if you're adding one dimension, you needn't change the contents, because you cannot change the contents, right? By adding one dimension, so whenever there is a mismatch, just make sure one of them is converted to 1, and after that you can see this operation happening, right? So is it clear to everybody? Shall I give one question on broadcasting, or do you have some questions on that? Right? So what is it happening? You are actually changing the shape so that it fits the broadcasting condition. Broadcasting condition is either of them is same, or whenever they are different, one of them is 1.
You get some reshape 2,
So
3.
the shape was 2 comma 3, right? See, what I did, 3 is same, 3 and 1 is different, but because you cannot, there is no more 3 here, so you made it 1 here, so that when they're different, one of them is 1. Okay, and see here, you have 2. This is different from this guy, you are adding 1 by 1.
That last 3 is what?
Last 3 is the shape that was present here, right? Earlier.
Okay, so in each dimension, it's single one, so it can replicate in each dimension. Then it will.
Okay, so suppose I'll give one more example. After that, I'll ask you guys one question. Okay, so say F is equal to NP array 1, 2, 3, 4, 5, 6. G is equal to NP array . So G shape is 1, 2, 3. F shape is 2, 3. How can you do operation between them? The dimension is itself different, right? Okay, so what you can do, got it? Okay, you have to make sure the shape is saved. Why this is needed, right? Suppose I'll give you one example of NumPy. We'll learn it later when you are doing k-means and all.
The last two is 3 dimension, right?
Mm.
Venus shape 1, 2, 3, 3.
Right.
That is.
Mm.
Can you tell the name of the argument we are passing to it? I mean, 1 is which argument, 2 is number of rows, and 3 is number of columns, right?
Yeah, I mean, at this point of time, just leave it. What is rows, what is column? I mean, just.
I mean, I'm not getting how you are writing the first argument 1, 2. In the previous example, you write 2, 1, 3.
Because your objective is to bring them to same shape, right? So, what is the shape of G? 1, 2, 3. What is the default shape of F? 2, 3. So, what we have to do? We have to add one dimension here, right? In the first case, that is why we did 1, 2, 3. Once the shape is same, you don't actually need broadcasting also. It directly will do it. Got it, right?
By default, we can just make it to same shape.
Right.
So what if the numbers are, let's say, of higher values?
You have to.
Possible here?
Everything is possible. You have to do those operations by yourself. I mean, you have to do the changes so that it becomes in the same dimension, then do the operation. I'll give you one question. I mean, and suppose that, I'll not give you a direct number question. It's suppose you have set of points. One set of points, and you have another set of points. What are the set of points? It is basically 1, 2. This is 1 point. Another point is 3, 4. Another point is 5, 6, 7, 8, 9, 10, 11, 12, 5, 6, 3, 4. Suppose these are two sets here, right? What you're doing here, you want to find, see what am I question? This is set of 6 points, this is set of 2 points. You want to find from each of these points which is the closest point here. Right? If you have to represent this in vector format, you represent something like this, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Right? If you have to represent this, so what is this is first set of points. What is the shape here? 6 cross 2, right? If you have to represent this, 2 cross 2, 5, 6, 3, 4. Suppose what you have to do, you have to from each point, you have to find distance between all the points, right? You have to do this using NumPy. How will you do using NumPy? Right. Understood the business cases. Like when you are calculating vector distances between a lot of points, you cannot do this using 2 times loop, right? That is infinitesimally slow process. You do that using this technique. What will you do? Say this is the code you have to write now. This is your A matrix. This is your B matrix. Okay. You'll do this A dot reshape 1, 6, 2 minus B reshape 2, 1, 2, right. So this will be the distance between these two vectors. Is it clear? Write this code. Okay, this will be like in one line of code, you are finding the distance between, from 5, 6 to all the points, from 3, 4 to all the points in one line of code. Here.
One thing, another thing.
Yeah.
So, for example, we're just subtracting these two. If I find the shape of the maybe it will be 2,6,2.
So what will I'll explain the output.
Okay.
So what will be the output shape? The output shape would be something like this, right? Has everybody done it? So that you can see the. Okay.
Can we okay.
So if you do this operation, the output shape, remember, will be what will be the output shape? Output shape would be something C dot shape would be, okay, this is the output, will be 2,6,2, right? This will be the output shape. Okay, 2,6,2 means there will be 6,2 matrix, right? If okay, that's what you should read this as. It's very important to understand how to read it. How to read it? There will be two 6,2 matrix. This is 6,2, and there will be 2 times of it. You can see, imagine 2 times it is stacked over one another. First matrix is distance between 5,6 to all of them. Understood? Okay, so how many of them will be 6? 6,2 will be there, right? 6 elements basically. Second element will be distance between this and this. So it will be 6,2, and second time it will be this. So 2 times 6,2 matrix. Understood why the output is that? Okay, visualize this. I mean, small numbers as much as possible. So that later on, when we discuss about finding vector distances between this data, that data, you should be able to visualize. Okay, that will solve. I mean, you don't have to read a lot of things to understand. Then if you start visualizing, you'll almost get that intuition. Okay, it will help you.
Can we control the shape? For example, A and B, we are reshaping to 1,6,2 and 2,1,2.
You can change
So
it. Like
C will be like 2 to the column will remain same. The column and C will be 2 only. Then in A and B,
you can do reshape after that.
Okay.
Okay, this will be the default shape. Like it will wherever it is 1, it will replace it with a broadcasted term.
Yeah.
One thing I couldn't understood this reshape, whatever you have done there, reshape 1,6,2 minus 2,1,2. I thought it would be 1,6,2 and 1,2,2.
No. You definitely can have multiple answers, but the rule is this, right?
Yeah.
Either they should be same as in this case, and wherever they are not same, one of them should be 1.
Let's say I have 6,2 and 2,2. So the shape of A and B, the original shape. That's right, 6,2, 2,2.
Right.
And so I'm just putting it on like I'm writing it down, 6,2 and 2,2. Now, so what you have said is, so wherever like 1 we have to add. So wherever that is same, we can just keep it like same. For example, your 2 and 2 are same, the last part.
Right.
So 2 and 2 are same. So I'm just keeping it constant. I'm not changing anything there. Now it comes 6 and 2. And first is, of course, nothing is there at the beginning.
Right.
So can I just add 1 and 1 there or no?
No, I mean, you will do whatever it requires just to make sure this rule is intact. I mean, and this is also correct answer. If you shape it to 6,1,2, right? First guy, and next guy, 1, 2, this is also correct. Okay, as long as you maintain that rule, you will get correct answers only.
Mine is 1, 6 and 2.
1, 6 and 2. Fine, no
1,
issues.
2, 2.
Huh?
1, 2, 2. No.
No, it is wrong, right? Because this is mismatch. Okay. Okay, clear broadcasting. This is broadcasting. Okay, broadcasting, it will happen internally by itself. And if it does not happen because of the rules, you might have to explicitly do that.
That's what we did.
That's what. So after this, okay. So you will use NumPy very much throughout this course. Okay. So we have discussed almost everything that is required to understand, unblock your machine learning journey. Okay, how to do linear algebra. Of course, the few thought points, you can do matrix multiplication here, np.matmul. You can do dot product. So what is the difference between dot product and a matrix multiplication? Anybody remember dot product?
Not product.
In the school you must be there, right?
We multiply with the same dimension.
Scalar and vector.
Right. The output of a dot product will be scalar value, right? Do you think you can do dot product of this? You're saying, right, same dimension. Okay. Let's see. This is A. This is a B, right? Can you do this A dot product B? A star B. Do you understand what happened? This is dot product that happened. Not dot product that happened. It is an element product that happened. Understood, right? Yeah. This is the element-wise product. Okay. And it is using simple broadcasting to element-wise product. Now, if you do a dot product, np dot A, right, then it is complaining, shapes 2, 3 and 1, 3 are not aligned, right? It seems that you are not able to do dot product in this case, right? What is required essential thing for dot product? Same shape, right? So what you can do is, shapes 1, 3 are not aligned also. Got it, right? Okay. 4 to the 8 plus 5 to the 10 plus 6 to the 12. 30. This is dot product. And what is matrix multiplication? Cross product. And element by element you have to see, right? So number of columns in one matrix should be equal to number of rows in another matrix. Okay. Just remember this term. There is one matrix. There is an element by element multiplication. There is one dot product. The element by element multiplication, the output comes is a vector or a matrix. Okay. Dot product is, the output is a scalar value. Matrix multiplication, the output is of size n, k, where the internal matrices are n, m and n, k. The output will be n, k. Fine, right? So, and for matrix multiplication, you have this API. Okay, anyway. Yeah, it's just it's anyway same is stuff, right? So if you have to make it matrix multiplication, 2 cross 3. So 3 cross 3. Okay, so A is 2 cross 3 cross 3, then got it, right? The resultant will be 2 cross 3. Clear? Matrix multiplication. Just keep this in mind. I mean, that's. You want to do. Okay, so you also have A comma T. This is transpose. Got it, right? Transpose of the matrix. Transpose means row becomes column, column becomes rows. Right?
If we take A and B both 3 cross 3 matrices, then I'm getting dot product and matrix multiplication product same. But for dot product, we should get a scalar value.
No, dot product only when it is basically a row vector. Then only we get scalar value.
If it is a matrix, then we get a matrix.
Matrix, yeah. Those elements are coming there, right? In what happens if you have a vector value and you do vector and vector operation, element by element multiplication, right? Then only you get a scalar value. Okay, so this is very important. I mean the thing, right? We'll see that many times. Okay, so this is a common syntax. When you do, see that's because it is vector calculus, right? So we'll see this term weight into x. But w and x both are vectors. Okay, so it will look like this here. Actually, this will be your weight 1, 2, 3, and this will be your x 5, 6, 7. So it will be element by element. Okay, so generally it is represented by WT. Don't worry, it will come there during linear regression and all that. Just as of now, just let's build the blocks. That's it. Okay, so we're done with the first stage of NumPy. Okay, so as an assignment, what you have to do is you have to do this part of NumPy problems. Okay, so now what we learn is we learn about basically we'll get introduced to pandas. Okay, and we'll learn statistics and visualization with that. Okay, so what is pandas? Pandas is a data analyzing library. Got it, right? Data analyzing library. I mean, with that you can actually analyze data. We can get more information out of the data. Okay. So how do you import pandas? Import pandas as PD. Remember, this is an alternative to your Excel sheet. In Excel sheet, you write this macros and all that, right? Okay, your pandas is a free alternative to that, and you can do much more complex operation than your Excel sheet. Okay, something that would take manually to do a lot of time, you can automate those entire stuff with pandas. The another important property of pandas is you can read the files of different format using it. In pandas, right? You can read files of different formats.
JSON.
JSON, CSV, databases. You can read pandas with databases.
What?
Okay, Words also, text file also, normal text file you can read directly. Let me see if I can install SQLite. I'll do that. So today let's read CSV files and all that. Everybody is aware of what is CSV file?
Yes.
Comma separated, or you can say Excel file. So okay, so there are a lot of CSV files in my, you can do this with me actually, huh? There are a lot of CSV files in my repository. What you can do is, okay, you can directly use it from here if you want. Yeah. Data, if you do this, adult data, or house rental data, let's do. Click here, you can see here house information, right? Square footage, number of floor, floor number, total floor, bedroom, living room, bathroom, and all that. So what will I do? I'll click on the raw. Just see the step that I'm doing. Click on the raw. Okay, you can directly read this file in. Okay, I'm in the next machine, so I have to open it here. See what I'm doing? House data. Of course, you can keep this file in your local file system. Okay, and just mention the path over here. Do it like this. Okay, house data. The first thing that you should be doing after loading the file is generally head. Head will show top, first 5 rows. Right? This is how it looks like. First 5 rows. Do you see something like, see here, this is the index number that is present in the file. Despite of that, in Excel sheet, you have this index column, right? First column is your index column. Automatically, it's appending one. You don't want that. You want this in actual data column to be treated as index. So what you can do is index column.
What is mean? What is this mean?
When you give index column is equal to 0, whatever column name, right? You are giving some column name as index. That means that column will be treated as index. Like if you have Aadhaar card information, Aadhaar card will automatically, if you mention this thing here, it will make that column as index. Understood? Right? Once right, imagine this is actually a table, or this is also known in data in Pandas word. This is known as it is also known as data frames. Okay, this is known as data frame. Okay, so what you did, you loaded a CSV file and created a data frame out of it. Right? If you have any CSV, you can load it and do this. This is the what is data. This is the data frame name. This is the head. It will show first 5 rows. If you want to see last 5 rows, this is the last 5 rows.
Suppose I want to retrieve 3 rows, not past rows. I just keep past 2 rows.
I will show you that. There is access. I will come there. This is a simple API. So first 5 there are, last 5 there are.
After adding this index column, I'm getting error. It says index column. Okay.
Spelling mistake. Space. Check out space.
Space is also like very much
important. Okay. You have to take care of the spaces manually.
In that we can do slicing also now if I want to have some.
You can do that. I will come there. There are different ways to do that. Okay. But understood head and tail. Okay. Yeah, guys. Next thing is info. See the steps, because this is like, you should be good with this by next week. I mean, you can spare some time over this week. Okay. So like loading the data, reading the data, getting some details. So you might have a lot of CSV files in your office. Just quickly load it. Do some EDA, explorative data analysis on that. Yeah. So this is part of your EDA, explorative data analysis, and we'll learn statistics along with it. We'll learn visualization along with it. Okay.
I think can you just scroll up? Oops, I'm still getting the error. I just want to see.
So see here, space here, space is here.
Under Wiki, I'm not getting any assignments here. It's machine learning for beginners, isn't it?
Go down. In the right hand side, you see NumPy problems. Is everybody able to load file?
Actually, yeah, after we have to load it.
Okay, so if you want to use my link, okay, go here. Everybody is here. Machine learning with beginners. Right. Once everybody got this file data, once you are in data, click this house rental data, and after doing all these things, you still have to click on raw. Raw. Put it in quotes and you will be all set. So you can download it, you can directly use it from
Just go there. House rent. Go to that URL. No, that site. Okay.
The index column part we will do for every CSV, right?
So this is the first phase. What you learned here, you learned how to load the data basically. Right.
You cannot give any other name to that unnamed. It is a keyword.
You can give anything. Other name also you can give it. But here, actual file name is the unnamed actually. So to give that in this case. Okay. So just okay. Is everybody comfortable with this so far? Okay. Just because when I loaded it came as unnamed. Okay, it automatically added. So to use that only here. Okay, see, in a real situation, this is still very, very simple way, right? In the major challenge that you guys will face is, the heterogeneity in data. The data will be so different, one guy from another guy, and sometimes comma create problems. Sometimes spaces create problem. Okay, so you, as of with experience, what will happen? You will be developing this confidence. No matter what your data is, you can actually eventually it will do clean, transform, and to a particular format in which you can deal with it.
I'm getting one error. Token something else.
Error tokenizing, etc. Actually, if you guys get any error, I mean, okay, what you do is you just write R before it. R, now do.
In the path,
Before path, right? Mention R. What happened? Or sometimes you might have to, if the formatting issues create problems, you might have to give encode type Latin. Right, encode Latin. Okay, so if it creates problem. Don't have Jupyter notebooks?
Spider.
Okay, you can try, if you face any problem here, right, you might have to sometimes give this encode type.
Spider.
And not encode type, encoding is equal to just write this. If you face problem, otherwise don't write it. Latin 1, I guess. Yeah.
what does it do?
It basically tells you if there is some formatting issues, right? This actually fixes that. Okay, the formatters note it down. You won't need in this case, but wherever you get this encoding error, C token and all that, I think.
So there could be multiple file reading operations. Let's say I want to see fifth to eighth row.
We'll get there. That is known as accessing lock, iLock. We'll get there. Okay, so after loading the file, okay, I'll show how to load it from databases and all that as well. Okay, but now I'll focus more on what are the various basic EDS that you can do. What is my data frame name? It is house details. House data. Okay, in house data, you can pass basically this function info. Info. If you do shift enter to that, okay, what are you basically doing here? Okay, you are telling here that these are the columns present here in the data set. Square footage, floor, total floor, bedroom, living room, bathroom, price. Okay, and these are the number of non-zero values in it. Non-zero, non-null values in it. That means these are what this means is this is the data that is present there. If there are some null values, right, it will show lesser numbers. Total number of rows is 645 and 645 of them is non-null. Right? If it is lesser than that, it will show as lesser than that. This is the type of the data. You can see here this is float, rest of them is integer. If it is string, it will show as object. Make sense? This is like brief summary of data. Brief. Okay. This is like you understand. So these are the columns that is present. These are the zero. This is a non-zero data that is present. This is the data type of it.
Usually it is called as metadata.
Yeah. This is metadata.
Information about the data.
Right. Okay. So there are more things that you can do. Understood this? This is like understanding in very simple lines, you understood what is there present in the data. Next thing you will do that now. Next thing you will do describe. This is also part of your EDA, explorative data analysis. If anybody asks you what is EDA, it includes things like this. You're trying to understand how is the data look? How does the data look like? If you do describe, you can see certain interesting stuff. Each column, it will tell you number of non-null values here, right? For each column, it is telling you number of non-null values. Okay. And the second thing is mean. So what is the mean square footage of house? It is 1527. Right? This is the mean square footage of house, 1527. Now, then you have floors. Right? This is the mean floor. Understand? That means for that particular column, this is the mean value. Right? The mean house price is 61K, around 62K. Right? This is the standard deviation. Okay, this brings us to the next. I mean, with this only, I'll keep on explaining these concepts. Mean everybody knows, right? Sum of data divided by number of data. That is your mean. Sum of Then the next thing that you have is standard deviation. How is standard deviation calculated? What is standard deviation first of all? Suppose standard deviation is how much the data is varying from the mean, right? Suppose you have certain data, suppose age is there, not age. So square footage is there, right? This is mean. That means if it is summing all the data, all the square footage and dividing it by total number of data, that is your 645 it is dividing, and this is the mean of it is getting. Then you are doing a standard deviation here. Okay, standard deviation is how much is it varying from the mean, right? How is standard deviation calculated? Okay, standard deviation of the data is calculated by
Xi minus 6.
you're in college or you passed out? Yeah. Okay, so others don't feel bad about it. Okay, it's part of it. Okay, so you know what is the formula? I is equal to 1 to, right? This is M is the total number of data. Okay, Xi minus mu. Right? Okay. This, what does it mean? Mu is what? Mean. Okay, it's really simple. So mu is, okay. So Xi is for each data, you're finding it out how far it is from the mean. Right? You're squaring it up because you know you might be in the left hand side or you might be in the right hand side. You might be lesser than the mean or more than the mean. You basically want them to bring in the same scale. Right? That is what your mean is doing here. Okay, that is what your square is doing here, and you are summing it up. Sigma means sum of them all. That is your standard deviation. What is your variance? Oh, okay, so standard deviation is, sorry, one more term, square root of this, right? So this was earlier, this thing was variance, right? So variance is square of standard deviation. That's it. Of standard deviation. At this term, whatever you got earlier, if you do a square root of it, you're getting standard deviation. If you're not doing a square root of it, you're getting variance. That's it. Okay. So if you want to see, you know, in NumPy way, how do you really calculate it? Do that initially because, okay. So np dot. Okay, I don't have imported. Import NumPy is np. np dot. Standard deviation. It is little tough to calculate. just made it a little easy to calculate. Okay, so if this is the data, what is the mean of the data? What is the mean of the data? The mean of the data is actually 3. I've just simplified it, right? 2 plus 3, 6, 6 plus 6, 12, 12 divided by 4 is 3. Mean of the data is 3. Okay, so I'm just mean of the data is 3, right? So a minus 3, what will this give you? This will give you difference from the mean. And then what you're doing? You're doing a square of it. NP square of this entire data. Oops, sorry. It's because 3 is the mean, right? Oh, sorry. You have to convert into numpy, right? NP. So if you do this, yeah. So what do you have to do? NP square. Okay, this is square of it. Now after the sum of square, what you have to do? You have to do sum of all them, right? And just writing it in separate line. I'm just doing all these things manually just to show it once. Yes. Then what you have to do? NP. After you have done square of it, you have to do sum of them, right? NP sum as S, right? So you get 2 here, right? So this is, and what you have to do? You have to do square root of it. What is square root of 2?
1.
What was the formula? 1. I mean, you basically have to divide it also, right? Okay.
1.4.
Yeah, and then you have to divide it by 2. Okay, that is what will give you this 0.7. So, okay. So that's what will happen. NP dot square root, right? NP dot SQ. Right, 1.4. Okay, and this entire thing divided by 2 will be, isn't this the same? Right. So okay, so that's what is happening over here. Okay, so rather if you do all these things, or you simply do this NP dot standard deviation and pass the value. Got it, right? That's what actually NumPy brings to you, or let's say all these things does here. Similarly, this is minimum, this is 25%, 50% of the data, this is max of the data. Understood, right? This is giving you normal this. Now, this is, remember, this will only be available for you for
why are we dividing it by 2?
this entire thing.
No, that NP dot square root, NP dot sum of s divided by 2.
You either do a square root of it, standard deviation.
There is n also in the formula xi minus x square divided by number of observations. Okay.
Oh, I have not written it here. Huh? Oh, okay, yeah. Okay. So it actually becomes like this. I mean, 2 became, because 4 square root of 4 is 2.
Okay.
That's why I directly divided here actually.
Okay.
Okay, let me show it. So here it is. It is the entire thing divided by m.
Okay.
Okay, I just directly did m square is there, so I did 1 by 2 of it. That's it. And so this thing comes up. Okay. So you directly do this standard deviation. Similarly, mean max, I'll just show it now. So for every column, okay, so you don't have to do all this maths. This maths will be done by your NumPy. For every column, if you want to know what is in, like, you had to have this data frame, right? House data. You want to access one column out of it. How can you access? SQ square foot. This is the entire column.
Okay, that's square.
That's square foot column. Okay. Okay, so remember there are two things here. Once when you give double brackets, okay, you can include, like, you don't want all the columns here, you want only this 2 columns, right? Got it? This is like selecting 2 columns out of those all columns. Double bracket. Double bracket will return you a data frame. If you give single bracket, it will return you a series.
All data is there. All data.
All data.
Suppose I have to retrieve all the data.
Then you don't have to do all this entire thing, right? Just write data frame name, it will give you all the data. If you want, so remember there is 2 things. One is series, one is data frame. As of now, whatever we have seen is data frame. Series means 1 column. Got it, right? Each column is series, and how can you access each column? You can directly do this, SQFT. See this. You can directly do this. Okay, or you can directly write this. So remember, this is SQF. This is a better way to do this. Okay, because if the column name has space separated words, this guy can handle it.
There is some indexing, like index also.
I'll show that now. Is it clear? Okay, so there is a Titanic file in my repository. You try loading that in the meantime. Here, right? Click on the data. You have this Titanic train. Load this file.
You're in which college?
Noida.
Noida.
I'm here for the internship for 2 months. That's why I was asking. I have to pay rights.
You're able to retrieve
Which one? That yeah, you have the path, right? So PD dot read CSV. What have you done? PD dot read CSV, no? We have
P. Yes. Read underscore CSV.
give in single quotes.
Single code.
But I don't think it should.
What is it?
D to P. Give D dot
D to
head. No, see, it is not loaded actually. When you are giving D dot, press tab. Tab. The options are not coming, right?
Acha, now we passenger ID.
See, P dot.
saying D is not defined.
Huh?
D is not defined. How come D is not defined? Input number plus P.
Giving. You need to take a raw. Raw. Go to that. You have not the correct path actually. Not the correct.
Raw UI.
JP groups. JP. नहीं तो मेरा इंटर्नशिप इट्स लाइक कि मुझे डेटा एनालिटिक्स का मार्केटिंग एनालिटिक्स वो है respective entity. So equal is the value.
Okay, everybody loaded the file. Yeah, you can see Titanic. It is actually Titanic data. Okay.
What is it?
Yeah.
0 means died and 1 means survived.
Right. You can see there is passenger ID.
Yeah.
Okay, which should be your index, isn't it?
Yes.
Okay, so the concept of series and data frame is clear. Series means one column. Okay, you can combine multiple series, like in this data SQFT. This is one series. Suppose my question is, what you have to do? You have to create a new column with all value zeros and add it over here. How can you do that? You can do it like this. New. This is adding a new column. Okay, and say if you do this 0, what it has done is house data. You can see a new column with all value zeros in it. Note that. Okay, what it will do? It will actually, and suppose you want to create a new column which is like price into bathroom. Okay, so price bathroom house data. Okay, house data price into house data. So it creates a new column which is function of house data and price. Got it, right? Okay, so this is how the operation is. Okay, now that we have learned loading the content, adding, generating new columns from existing data and all that, we'll learn how to access data. Accessing the data.
What
this raw like code, markdown, and then you had something raw also.
Hmm?
That drop down you had code, markdown, and raw.
Oh, when you choose markdown, right, corresponding to one data, okay, it becomes a HTML tag. So you can add image and all. Okay.
And what is raw?
Raw is not much useful.
Okay.
Code and markdown is the one. Okay, raw means whatever you write it will be as it is. Markdown will be treated as HTML code. Okay. So, okay. So this is your house data, right? Say here I want to access by data by index. Okay, for that you'll use the function iloc. Access data by index. So dot iloc. Okay, so what you're telling, you want to access 3 to 6 data. Okay, so you can see here, this is, okay, idoc. This is third index, this is fourth, because you see the data is starting with 1. Understood, right? You can see here data is starting with 1. So this is was 0, 1, 2, 3, 4, 5. 6 will be, got it, right?
Yes.
So the iloc means accessing data by index. The important difference here between iloc and iloc. This is iloc. See what happens when you have lock 3:6 lock. So the lock means it will use the index value, not by default index. And iloc means actual default index 0, 1, 2, 3. So in case of lock, you can also give name. If you have loaded Titanic data, you can give first name, or you can use those information also, which is not index values. Okay, but remember in that case it has to be index. So for example, I'll load a JSON file. See here, there must be some JSON file. I think it's not here directly. You have this movie.json file directly. ed.read JSON. See, you can see this is the movie name and all that. So you can see what is the index here. Index is the name of the movies. Movies.
Oh.
Yeah. You have movie. You can do this lock, right? Give some name. What is, so let me see the data first. The data, right? You do movie. Goodfellas. The starting point. Roman Scarface. Okay, so you can see here, this is your. Got it, right? Understood, right? What happens? Okay, and if you give here indexes, 1, 3, see, data 1 and 2 is coming, of course. This is based on indexes, that is based on values there. Is it clear? This is accessing. Of course, you can, like if I ask you how to access data, alternate data you try to access. How do you do that? Colon. Is it? That's one.
Minus a comma
2. Yeah, this is alternated. This is similar to a list stuff, right? Okay, so it is your similar access, alternate data you're accessing. And if you want to mention, from 1 to 100 data, you should be accessing alternate. Clear? Okay, once you have done all these things, you want to write it back to a data frame. So you can write to CSV, small data, small.csv. Right, if you would have written this file, you can see here small.csv getting created. Got it, right? Once you create or manipulate the data frame, you want to save it back as a CSV, you can do that. So if you see here, this is a CSV file.
Do underscore CSV, so automatically create a
CSV file
CSV.
of whatever data frame is present at that point of time, it will create a
CSV.
right.
In the same path.
Right.
Suppose you have to create some different paths. So here you can give.
Right here. Got it, right? So what you should be doing is yesterday I was not showing you guys, I guess. You have a lot of websites from which you can get a CSV file. I would highly encourage you to, there is a UCI repository, UCI machine learning, UCI. Yeah, so UCI repository is there. I highly encourage you guys to actually, click on like wine data. You have click here on the wine data. This is any data actually. Okay. So what you would do here is you basically would save the file from here. You can download. Go to data folder. Okay. You can download this wine data. Got it? Or you can actually do this. Okay. You can copy this URL the way we are doing for our earlier our data, but directly do the process. Got it, right?
But this is we still use read underscore CSV, but this is a dot data file.
That this file name does not extend. Just as long as it is comma separated, it will be able to deal with that. Is it clear? Okay. So just revise this broadcasting concepts. You guys are coming tomorrow, right? At 8?
Yes.
Tomorrow we'll be starting with machine learning actually in that batch. So how much you need to attend the next weekend batch also. Okay. Anyway, more or less I'll talk about what is required, but like pandas, numpy, and all that. Should be fine. Let me know if you face any difficulty.
This Pandas machine learning, how much is messed up?
From now, it is around 7 to 8 hours.
7 to 8 hours.
On the 1 weekend mode.
1 week. Okay.
1 weekend mode plus.
So you will give a quick revision after it. Will we be missing something in the tomorrow's class because we have missed that?
Ideally, no, I should be able to follow.
Okay.
Because it's a little orthogonal topic, little more maths, internal details. Okay, should be able to follow tomorrow's class.
So basically what like that the first day when you have noted down the topic for data analysis, these things are missing.
These things are missing, yeah.
So we'll be doing only the maths part tomorrow? Or we'll be starting with feature selection as well?
No, not features. We'll be doing linear regression.
Okay.
So maths part, whatever is recap, I'll recap it. No problem.
So these things are not required, like probability and this.
Not now. We'll be requiring it in the next session.
Okay.
So I think that by Friday you'll be next weekend. You'll have to continue this batch.
Okay.
Any questions from today's stuff?
One thing. So here we are accessing the data, but we are accessing only the rows. Like what if I want to access only few columns?
That we should.
Like,
Double bracket and give the column names.
when we are doing slicing, can we just give a comma and give?
Not comma. You want to access certain rows, right?
Yeah, just. This is the last one. Just like if I'm having house data 1:100, colon 2. So those many rows I'm selecting, and I want to select columns only the first 4 columns.
If you want to mention the column names, you can mention it like this.
Or I can mention like 1:5 if I want to access first 4.
Actually, that is not very recommended.
Okay.
So it will always mess you up. So you better do this. House data dot columns. Okay, you want first 4 colon 4.
Okay.
That you get this data. So this data, earlier it was allowed. Nowadays it discourages it with this list. So pass this data in here.
If I want selected columns, then better to just give the column name.
Right.
So Pandas is like supports only for to CSV or that Excel sheet and is there like we can play around in Excel sheet also or only CSV?
No, Excel sheet also you can use.
Like the 2 column and concatenation. So you 1 column. How to 2 column is there. Like that floor and square feet is there. Like that. I concatenation 2 column showing 1 column.
Concatenation is sum of these two, or just 5 and 7.
7 on. And another column I want to show this.
New column equal to this.
Is it clear? You want to create a new column?
Yes.
That way, just give a new any column name. Right here we were doing right. Like this, right? Fine. Okay, so you understand now how to load this file in your HR data. So what you have to do is, just run that code.
Yeah.
Just make sure this is this file.
Yeah, I saw that.
HR data you saw, right?
Yes.
Okay, what you have to do, this file, you just have to make it accessible. Shift enter the entire code. Okay. It will execute. Any questions, anybody? Okay, let's catch up next weekend.
So for pandas, like only this much.
No. This is just loading of data. So in pandas, we will learn about, this is loading and accessing information. Then we learn about filtering information. We learn about grouping data. We learn about, altering information, like transformation.
So this is the data I'm getting right now. Now here I want only the living room. Like from here the living room. So what expression I can I write like
No. If you want to column-wise access, you better do it this way. Where you're giving column names.
column names?
Dot
But column names I do not want all the rows. I
Each
just-
row. First, so you have to first filter the rows, then get the columns, or filter the columns, then get the
So
rows.
I have filtered the rows. So this is incrementing to
And after that, give another brace. After that,
Now I want columns from square feet till bathroom.
so after that, do this way. No? This is what I did here, right? Give another bracket which mention the column names like this here.
House data. That is the only way we can do that.
This is the better way. Other way is fancy indexing, which is not recommended. You can search and later on you stumble upon that. This is a cleaner way that works. That is more confusing than it's all.
Is there an assignment for us?
Assignment is your machine learning for beginners NumPy assignments you have to finish. Then pandas, we haven't reached that stage, but once we get there, you have assignment in pandas as well. Okay, pandas assignment. Okay, this is one assignment, and assignments is there. NumPy problems.
Pandas assignment.
So anyway, this is one data you can actually try processing it. Okay, here is some sales data. Actually, you try loading it. You have to create an account in Kaggle. Okay, Kaggle is a place where you will find a lot of competition happening, data getting over there. So you can try loading this data. There is one. Something changed.
Everything is auto saved in Jupyter, right?
So I was also looking for the morning lectures. Saturday mainly. Saturday I can come back.
We try coming tomorrow.
And see if I feel able to go back. Then I will continue. Otherwise, I will stick with this only.
So tomorrow 8.
8 to 15.
8 to not 8.
9 to 1. Not 9 to 1. I'm sure. So this will get saved and you will have a system also.
Which one? No. I mean, this gets saved.
Only this one.
Mine will have to upload it and you will. Okay, I'll upload in the repository.
No. That is just asking for.
Yes.
Thank you.
Thank you.
So
Will you share the code what we are writing? The code is yes present in community, but whatever I'm writing, it's you can go anywhere writing it. Yeah.
So I saw some online sites, so they will just directly copy the URL like in the request. I mean this request URL. But when I was checking online, then for using data, do I have the information?
But the API like validates you as an entity who is eligible for this data.
How can I get this?
You have to create an account and mail them. Just search for
Developers group.
Developers group. There you will share this.
Otherwise, it's not possible. So I have to get these information and get that from LinkedIn. This developers group.
See my apps.
But I don't have any app. Then how
You
can
don't have to create one app. You just go through this journey.
Okay.
Create my app, then create one app.
Hmm.
It's free only, I think, to some extent. Okay. Do that. My apps, and it will give you the key and ID.
Then in another thing, when I'm scraping, when I'm getting this source code, then in the videos, the guy is just looking at this and finding that this tag is inside class and dev and dev. So I have to check it manually for every class.
If you want more information on this, you can check with Kunal. You have done Python here, or
No.
you can check with Kunal. He takes care of all.
Okay.
Okay, he might have some ready-made information that can be handy for you.
Yes, I saw some Python library for LinkedIn scrolling.
If you get stuck somewhere, if you want some help, some quick information, Kunal can help you. Okay. Kunal, you can check with Amitesh.
Thank you.
So you will share that this file today.
I'll upload in the same machine learning. Both the files uploaded. Same machine learning for beginners, right? From there itself, I'll check with batch 21.5.
Can I hear any problem like that? You can think it.
I think drop in mail. Because how will you think?
Yes.
Yeah, drop in mail that Avantik Das has seen that.
Spelling?
Yes. And
Where you from this?
not from Assam.
That's machine on that side vehicle.
These are from Odisha.
Yes. Assam and Odisha language are similar.
Very similar language. Similar in the languages.